All right, hey, this is Gigi. I am going over written assignment number 16. I want to go over number 3. I skip over number 2 because what I am showing you here in number 3 will involve the things that are being asked in number 2. Okay, so first of all, let's understand what the question is asking. It is asking you to find the power series representation for the function g of x. In this case, it would be this right here. Okay, so that is your g of x. And we want that in the route of this one. So first we need to know what f of x is, and then we need to recognize what the relationship is between g of x right here and f of x. Okay, so let's think about this for a second. This is some thought process here. I am seeing f of x is x over 1 plus x squared. Okay, now if you think about the relationship between ln and some fraction, we might want to think about this, right? The integral. What if you integrate both sides? What would you get? Okay, so the integral of that, we can go and do a u-sub, right? Let u be 1 plus x squared. So du would be 2x dx. So that x dx is 1/2, not -1, but 1/2 du. So this right there becomes the integral of 1/2 1 over u du, which is ln of u plus c. And that is, so that would be 1/2 times ln of 1 plus x squared, right? Plus c, that is equal to the integral of f of x dx. Okay, so what is the relationship between your g of x right here and what the integral of f of x dx is? Well, I think if you multiply both sides by 2 here, you can see that ln of 1 plus x squared is going to be 2 multiplied by the integral of f of x dx, right? So that is the goal right here, to go and find out what f of x is, and then take the integral and then multiply by 2. That's how you are going to be able to obtain the function g of x. Okay, so that's, now we have sort of a plan, right? So let's just go and find out what f of x is first. Okay, so where do we start? We start with the geometric series, which is 1 minus x. The function 1 over 1 minus x is equal to 1 plus x squared plus x to the third plus x to the fourth, and so on. And that is your geometric series. Now, we don't just have 1 over x. We actually are having the denominator of 1 plus x squared. Well, what does it mean when we say 1 plus x squared in terms of 1 minus something, right? Remember how that something, that's the box that goes there, and we're going to do a little substitution. So what is that thing right here? That would be 1 minus negative x squared. That is the thing that goes in the box. So this is going to be 1 plus, instead of x, we have negative x squared. And then we have negative x squared squared, and then negative x squared to the third plus negative x squared to the fourth, and so on, and negative x squared to the 5th, and so on. Okay, and then what else do we have? We don't just have 1 on the numerator. F of x is actually x over 1 plus x squared. So now we can say that x over 1 plus x squared. Well, what are we going to do to obtain that? Multiply everything by x, right? So if we multiply this by x, we will get where we need it to go for f of x and multiply everything by x. When we do that, then we will have x. Oh, let's clean this up for a second here before we go there. When we clean up this series here on the right hand side, we'll have 1 minus x squared plus x to the 4th minus x to the 6th plus x to the plus x to the 8th minus, because negative to the 5th power is negative, x to the 10 and so forth, and we can see that the signs are alternating. Now let's multiply that by x. Multiplying that by x, you'll have x minus x to the 3rd plus x to the 5th minus x to the 7th plus x to the 8th minus, oh, that's not 8. One more will make that 9. And then one more would make this 11, and so forth. Okay, again, what were we going to do to this function? That right there is f of x. We're going to go ahead and integrate it and then times it by 2 to get g of x, right? So let's go and take the integral of both sides. So when we take the integral of both sides, we will then have 1/2 ln of 1 plus x squared. Okay, as we see here earlier when I started out with the u substitution right there. Okay, so I will have 1/2 ln of u plus c. So that is equal to, let's take the integral on the right hand side. So the integral on the right hand side is going to be x squared over 2 minus x to the 4 over 4 minus x to the 6 over 6, and actually plus, the sign has to be alternating, x to the 8 over 8 plus x to the 10 over 10 minus x to the 12 over 12, and so on. Okay, so we can see now that, and to undo 1/2, we'll multiply everything by 2. So then, our final thing to do is ln of 1 plus x squared, which is what we wanted, is 2, and let's write the sum. The sum of what? I'm going to need some room here. Okay. The sum of what? We're looking at all the odds, right? We're looking at all the odds. Let's say if we were to start at 0, how do we manage this? X to the what power? Well, we want to have 2 there. So even is normally 2k. But if we start at 0, if you plug in 0, you're going to have 0. So you're going to have to add 2. Okay, so let's see if that works. And then the denominator will just be whatever the number is on top as the exponent. So let's check. When k is 0, you have x to the second over 2. And then when k is 1, you will have 1 times 2 is 2 plus 2 is 4, right? So that's good. When k is 2, 2 times 2 is 4 plus 2 is 6, so we're good. Now we are alternating in terms of the sign, and it starts with a positive, so we'll say negative 1 to the k power. So that is the series of ln of 1 plus x squared. Okay, now, if we really want to, you see that 2, that could be canceled with the 2k plus 2 here, if you want to look further. Okay, so if you want to look further, you would say, hey, all of them have a 2 and divided by the 2 here. So that could be sum going from 0 to infinity of negative 1 to the k power, x to the 2k plus 2 divided by, divide everything by 2, you have k plus 1. Now, the question also asks us to go and find the interval of convergence. So what are we going to have to do? That would be going back to problem number 1. Now that you get this series, you will ask yourself, when does it converge? So that means what is the interval of convergence? How do we do that? We either use the ratio test or the root test. Which one do we want to do here, ratio or root? Ratio test. Okay, so you check. You check for your interval of conversion, and that is just like problem number 1. The center is at 0. Question is, how far can we go? And what is that? And what is this interval? All right, so your job is to go ahead and finish this problem. Now this part where you have to substitute, this is what I mean for number 2. Number 2, what you are doing here is you're doing the substitutions and things like that, right? So the question number 3 is involving question number 2. So now you've seen how it's done. You should be able to check your process in number 2 as well.